Hello, Math 30. Now we put everything we've learned together. And we now take it one step. So the learner outcome for this is I can use identities to solve tougher equations. We've already learned how to solve simple trig equations where we've got one ratio. But now you're going to see more complex trig ratios that require us to make some substitutions using some of these identities we've learned. And the reason that we're doing it is we need an equation that's in terms of only one of the three primary trigs. So when you look, this doesn't seem so bad. Tell me the answers from 0 to 2 pi. But the problem of this is, oh my goodness, we've got cosine squared and sine x. It's two different variables within the same equation, and that makes it a real challenge to solve. So the trick is, can you take one of these, and there is no perfect way to do it, can you take one of these and make a substitution with an identity that allows you to have one variable? So you need to ponder that. So here's an example. So for this one, let's do it together. So for the first one, I think I've got a Pythagorean identity. I look at my formula sheet and I can see that 2 cosine squared, I can change that into 2 times 1 minus sine x squared, plus the 3 sine x that I still have here. Now I know that that's 2 minus 2 sine x squared plus 3 sine x. And I'm going to take it all to the other side. So now I'm going to have 0 is equal to 2 sine x squared minus 3 sine x minus 2. And now I look at that and I remember an expression like that, and I can factor that. And when I factor it, we can use decomposition or whatever method you choose. Mr. K is going to do just guess and check. So I know that this is 2 sine x because that's a prime number, and I know this is sine x. And because that's a minus 2 at the back, that's a prime number as well. So I can see that what would work is putting a minus 2 here and a plus 1 there. In doing so, I now get a nice little equation where in this factor, the sine of x must be equal to negative a half. And in this factor, the sine of x must be equal to 2. Clearly, this one has no solution because that one, sine can never be more than 1 or less than negative 1. But for this one, I know that the reference angle is equal to pi over 6. And I know that it's in quadrants where sine is negative, so that's here and here. And therefore, x is equal to 7 pi over 6 and 11 pi over 6. And question A is done. Okay. We look at question B. And in question B, you look at that and, well, you do have one variable, but you have these sums and differences, and you can't simply get sine is a half or so on. So again, look at your tools. What tool do you have to rewrite that? Look at your formula sheet and rewrite that with the tools you have. So in question B, as we rewrite that with the cosine sum and difference identity, that's the expression or the equation we now have. We look at that carefully and we see what we can do with that. Well, I don't know what cos x is, but I do know the sine of pi over 6. That's, excuse me, the cos, oh, I have a mistake there. This needs to be cosine. Cosine of x, cosine of pi over 6. So this ends up being root 3 over 2 cosine x minus the sine of pi over 6 is 1/2. So that's 1/2 sine x. We have to make sure that we consider distributing that negative to both of those terms. And as I do so, I end up with minus root 3 over 2 cosine x, and I get minus, excuse me, minus 1/2 sine x is supposed to be equal to 1. When we put this all together, what do we have? Well, we end up with minus 1 sine x is equal to 1. Final answer, sine x is equal to negative 1. And from 0 to 2 pi, that only happens at 3 pi over 2. And I'm thinking on the unit circle or by using the trig graph. I didn't do a reference angle or anything there. Okay. And lastly, before we move on and do our assignment is, when you consider this equation, once again, you have sine and you have cosine. Which identity would be best to use in order to make this question 1:1 trig ratio? Seems to me that the best thing to do would be to take the cosine 2x and turn it into 1 minus 2 sine x squared. And you had a couple of options to do there, but that seems like the best option to me. Again, there are roads less traveled, there are other ways to do it, but it seems like that would be the most efficient replacement. Now that we make that replacement, we get 4 minus 7 sine x is equal to 1 minus 2 sine x squared. And this is 2 sine x squared plus, minus 7 sine x. And we end up with 4 minus 1 is 3 equals 0 as we take everything to that side. And once again, we need to factor, but I can see two prime numbers, so I don't really feel like using decomposition. I'm going to say that's 2 sine x times sine x. And seeing as though that's a plus 3, I'm betting that this is minus 3, and that's minus 1. And therefore, I get sine of x is equal to 1/2, or the sine of x is equal to 3. This gives me no solution, because you can't have it more than one. And if I give myself some room and come over here for that particular one, it means that the reference angle is again pi over 6, and it must be in quadrants where sine is positive, so 1 and 2, and therefore my first two answers for x are pi over 6 and 5 pi over 6. However, that was not what it was looking for, because in this one it asked for the general solution. So we have to make sure we underline those things. And the general solution is when x is equal to pi over 6 plus 2 pi n, where n is an element of integers, or x is equal to 5 pi over 6 plus 2 pi n, where n is an element of integers. All right. And now we can complete our assignment. And that's the end of trig identities.